Welcome everybody to Every Event Everywhere All at Once. First of all, thank you very much for choosing this and giving this your time and attention, because I know there's lots of options and time and attention is your most precious thing, so thank you for coming. I'd also like to thank Devox for colour matching my hair with the t-shirt they gave out, so I had to wear it today. So, okay, Every Event Everywhere All at Once. Now, this talk exists because all the terminology around events is quite discombobulating. It's confusing, makes you feel a bit and so this is a disambiguation talk to help you feel happier about all the different terminology that typically has the word event in it. So I'm Jacqui Reed. I'm the author of Communication Patterns with O'Reilly, and I'm a principal architect at the Ministry of Software Design, and we help businesses to fully own their software products through software design and architecture. You can find me via my website or via all these socials, and I'll be sharing the slides via those socials at some point in the near future. So follow me on there if you would like the slides. Now, originally, this talk was going to be an A to Z of events. But the problem with that is that they pretty much all begin with E. So it doesn't really work. So what am I going to do? Every event from everywhere, all at once. And so it's still sort of an A to Z, but it's in an order that we can build on prior learning when we are learning new things. So A to Z doesn't allow us to do that. Okay, start from the beginning. What is an event? And it's one of these things that means different things in different contexts. Now, if we look in the dictionary, the most basic definition is an occurrence or something that happens. So we don't really know when it happens, but it happens at some point. Another definition is a prearranged social activity. Now, this is actually one of the most confusing things, because this is the type of event that we come up against all the time in our daily lives, because it's actually talking about what we can call a calendar event. And so this might be something like a party, it might be a medical appointment, maybe it's a flight or a train, but generally it's all about time and date. But the thing about calendar events is that they can be in the past, they can be in the future, and they can be happening now, like this talk and this conference. And timing is the biggest difference between a calendar event and a software event. Now, if we look at this definition, this is the one that's actually closest to a software event. So it says an end result, an outcome. Now, here's my nice high-level definition for you. A computing event is something that has happened. And that is very important. It's in the past tense. It has happened. It's not going to happen, or it's not happening. Now, events have actually been around for quite a while. They have become a lot more popular with the rise of event-driven with distributed systems. But if we have a look here, this is from the Java ecosystem. The class event object came out in JDK 1.1, which came out in 1997. Who remembers what else came out in 1997? Anyone know what I'm talking about with the llama? Or are you all too young? Pardon? Winamp. Yes, Winamp. Very good. So Winamp came out in 1997. Some of you might have been in school. Some of you might not have been born. That's a scary thought. Right, let's move on. Now, the interesting thing here is that lots of these subclasses refer to things to do with the UI, and then we've got a couple here that are to do with changes. Now, let's have a quick look at these compared to the kind of computer events we have today. If we look at this preference change event, the first thing we can note is that it's not in the past tense. It's not changed, it's change. So that's one difference. The other interesting thing is that it is actually modeling 3 separate events. this preference may have been added, might be a new one, it may have been removed, or it may have been changed. Now, sometimes it's okay to model things like that. It depends on your situation, but quite often that can cause some issues, which I'll talk about in a minute. Now, one thing here that is similar is that the event is essentially a wrapper for the state, what has changed. And so here we've got a key, which is the identifier for what thing has changed, and we've got a string, which is the new value. But we've also got some of the logic for working out how to set it, but also how to read it. So it says that the new value is going to be null if the preference is removed. So everything that consumes this event is going to have to put logic in to check whether this is something that's being added, something that's being changed, or something that's being removed. And if something only cares about, say, removed events, it's still got to check every single event every time, and then just forget about the ones that aren't the remove preference. So it can cause some problems there. But also, you are coupling your things within your system. So if you suddenly go, oh, actually, it's not going to be null, it's going to be an empty string. Everything that consumes that has now got to change. And people will just change arbitrary things like that. You know that. Okay, moving on. It's really important to understand the difference between an event and a command. They are both types of messages, and messages are all about getting information from one place to another. So let's look at what makes them different from each other. First of all, a command is an intention and it is sent. So we're saying, do this. You know who you're sending it to. It might be just one recipient. It might be multiple recipients. And in this case, you're going to have to handle problems if things aren't done as you want. If there's an error, you might have to roll things back. You might have to do retries to make sure that everything is consistent. And a command example here would be change preference. We're talking in the present tense here. And then with events, these are a fact which is published. And basically the producer is just saying, this happened. I don't care if nobody listens to me, or I don't care what you do with this information. This happened, do what you will. And so the producer doesn't know who those consumers are or care. And with events, we can have these different transactional boundaries depending on how they are distributed. And we've got an example here. This will be preference changed because it happened in the past. So the producer says, this has changed, and everyone just does what they want with that. Now, there's a good post by my friend Oscar, who talks about the difference between commands and events. And he uses this meme to talk about the intent of a command and the result of an event. So it's a good way to remember it. But one other way to think of this result is it's a fact, because it's immutable. It happened in the past, and we can't change that. So events, immutable, and in the past. And we can look at this by looking at a work item within, say, a to-do or a ticket managing system. So say we create a work item. That's the command. The state of that work item is to-do. The event would be work item created. And a message, as I said, can be anything. So this is, I like creating work items. Don't like doing them, but I'll create them, put them on the to-do list. That's fine. So if we start that work item, it becomes in progress, it was started, and the message, again, can be whatever. Then we complete that work item, so it becomes done. If we're sending that as an event, it's completed. And of course, high five, well done, you have done that. Now I said that these are all actually messages, because messages are just information from one place to another. So you can think of it sort of a parent class of all of these. But a message isn't necessarily a command or a event. Okay, next one. Event listeners and event handlers. Now, these are very often used interchangeably, these two terms, but we can break them down semantically. So first of all, we've got an event listener, and what it does is it listens for a specific event. So someone actually named something correctly in software. It does listen. You can think of it as a subscriber as well. So it's looking for a particular event. When that event happens, it then will trigger a callback function. And that works asynchronously to respond to that event. And whatever that function does is what is the response to that event. Now, you can have multiple listeners that all trigger the same callback, if that's what you want to do. But sometimes that callback is referred to as a handler. Some people might call it that. But the whole thing together is what is typically known as an event handler. Nice and simple, but when people refer to things differently, it can get very confusing. So there you go. Okay, event streaming. This is a good one. Continuous flows of data. So when you have streaming data, this data is not coming to rest. This is going to allow you to respond to things happening in near real time, because it will come in and you will be able to read it off. Now, the way we do this is using an event streaming platform and APIs attached to that platform. Now, this is going to be an analytical use case. So this is the kind of thing which you might do in batches or have done in batches. Maybe it's a big thing that happens overnight, or it's just something where you just every 50 times something happens, you batch process it. So this is the alternative, which means you can react in near real time instead of going, oh, the next morning is when we're going to react to that. So what you have is producers, things like microservices, IoT devices, and these send events to the event streaming platform via APIs. Then that event streaming platform is going to store those, and different ones will push or allow you to pull from them, so it depends what platform you're using. But then you've got consumers who consume those events. Things like data warehouses and OpenSearch are some examples there. Now, under the hood, what it's doing is it's using a message log. So what better fictional example than Star Trek, because they're always creating captain's logs. Right, don't be embarrassed. Hands up if you've ever watched an episode of Star Trek or Star Trek film. Quite a few. Keep your hand up if you've ever seen The Next Generation. Oh, there's loads. I thought it was going to be like one. Okay, I don't feel so old now. Okay. So, captain's logs. So we've got a producer that is creating logs which are being put into this message log. Now, they all have an offset which determines sort of the order that they've been put on, the order they're going to be read. And so the consumers will consume these messages based on that offset. Now, what they will do is they will record the last processed offset every, say, X messages or every Y seconds. But what happens if one of those consumers has a bit of a problem? So, go on, who recognises Q? Oh, a few people. Yeah, so he's from The Next Generation. He causes trouble quite often. He was in the very first episode. He's in the very last episode. So his name is Q, as in the letter Q. So he's causing problems, takes down your consumer. When it comes back up again, it can go, what was the last offset that I consumed? And it can start again from that. But you do need to take into account idempotency, because maybe it processed, say, number 2, but it had only stored the offset of 1. So it may then process things more than once. And so you need to make sure that if it processes the same message twice, you get the same result as if it only processed it once. You don't want to be adding extras to your totals or anything like that. So do take that into account. So that's a message log. That's streaming. The other thing we can use is message queues. Now, it's important to understand the difference between these two. Some products now which offer message logs also offer queues and vice versa, or if you're trying to choose between products, you need to know the differences between these. So, message queues. I'm British, I know about queuing. I can tell you about this. Okay, we've got a producer puts things onto our queue, not that kind of queue. And then we have our consumers, and they are going to consume things from the queue. Now, when they successfully consume something from the queue, they will confirm that they have done that. What happens first is that they say, I'm going to use this, and the queue won't give that to anybody else. But if they don't say, yes, I have processed that, the queue will then make that thing message available again to other consumers. So if one consumer takes something from the queue but then doesn't finish processing it, then another consumer will get the chance to do it. And now, event-driven architecture, or EDA. We can implement EDAs using streaming, queues, message logs, and some options. So that's why I'm doing it in this order. So now you know what's under the hood here. Okay. Earlier I talked about commands. If we have a distributed system that is command-driven, then it can look a little bit something like this. We've got lots of services who are sending commands to each other. They know who they're talking to. Generally, they're sending responses saying, yep, I've done that, or here's the answer to what you asked for. It can be synchronous, it can be asynchronous. So synchronous things will stop the processing if service A has talked to service D there, service A is not going to do anything more until it receives a response. Whereas if when service E talks to H, it can carry on doing other things, and then that response will come back. Now, the thing with this is that we are creating lots of coupling there. The thing we really need to think about is that when we are creating that coupling, we're going to have to think about using things like backwards compatibility, maybe consumer-driven contracts, to help us to manage that, because otherwise you make a change in one part of the system, push it to production, and it breaks another service, which is not what we wanted with distributed systems. Now, when we look at event-driven, we get normally something like this. So this is a similar system. All of these services are publishing to a broker, they're publishing their events, and they are subscribing to any events that they want. Now, this might be using queues, it might be using message logs, streaming, it might be a mixture, although that's going to push up your cognitive load, so you have to have a really good reason for having a mixture in there. Now, you could think, oh, wait a minute, there's a bit of a bottleneck or a single point of failure in the middle there, and there's lots of things you can do. You can say run it serverless, you can have more than one instance running. Those are some options. But the interesting thing about this diagram compared to the last one is that it doesn't tell us who's communicating with who. You can't now tell that from your diagram. But I talk a lot about diagrams, and I can tell you that not all information should go in a diagram. If you want to know who talks to who, why not have a table of data? It's much easier to keep that up to date, or even just a bullet list in a wiki page. Easier to keep text up to date than a diagram. Now, what we get with these distributed systems is we get what I call a wall of ivy. Now, all the data flows are the stems in that ivy, but if you look at that wall, you can't see most of those data flows, can you? So we can do things like look in that broker to see who's communicating with who, but this is just a fact of loosely coupled distributed systems. And you're going to have to really look at your knowledge management to help you with that, having that information, or even working out whether that information is really needed. Do you need a huge long list that keeps being needed to update? You keep needing to update when things change. Maybe things don't change, so you could create a list. But if no one's looking at that list, why bother? So think about what you do need to have in your knowledge management. Next, there's lots today. Event storming. This one is the one with the sticky notes. Now, quick poll. Who has used or knows what event storming is? Few people. Not a huge amount. Interesting. Okay. Let's look at what it is and why you might want to use this. So big picture event storming is the thing that you are most likely to come into contact with. But you need to know what all of these different sticky notes mean. So the orange ones are events. So these are all going to be in our past tense, things that are going to have happened. Then green ones are opportunities, where we've gone, we could take advantage of that. These pinky red ones are hotspots. These are where there are problems, or maybe you've got people disagreeing about what does happen or what should happen at that point. And these are typically rotated 45 degrees to make them much more obvious. We then have little yellow ones. These are actors, things like people and systems. We have these little voting arrows, and I would recommend putting some initials on there when you vote, because then when you have discussions later, you know who's been voting. And then we've got these big pink ones, which are systems. Now, if you do use this, it's good to stick to these colours, but you don't have to, and you don't need exact shades either. What you do need to do is create a legend like this. Whatever you use, create a nice big legend that everybody can see so everyone knows what you are using. Maybe you haven't got any orange sticky notes and you have to use the standard yellow ones. So just put that in a legend. Now, big picture event storming. Basically, what you're doing is you're getting together all the relevant stakeholders. These are things like subject matter experts, technical people as well, so it might be architects or tech leads. And what you're going to do is you're going to collaboratively map out how things work. Now, this might be a greenfield project where you've got to work out how it's going to actually work, or maybe you're mapping out how things currently work now. And what you're doing is you're trying to understand all the workflows, sort of break down all these silos of knowledge within your organization. And you're going to pinpoint the pain points and problems in your system. Say that 10 times quickly. Now, I'll give you a quick example. In here, it's got to be Star Trek based again. So we've got ship docked, happened in the past. Resupply started, resupply finished. And this is all to do with the space station stores system. And someone said, do we need to worry about separate stock types here? Do we need to sort of break this down even further? Maybe we need to break this up into several different series of events for different types of stores. That's something you can then look at in another session. And this brings us nicely onto pivotal events. Now, these are going to be the candidates for your system boundaries once you've created this. And they're usually indicated by this sort of yellow line or tape once you've identified them. Now, these are often the events where you've got the most people interested. You're going to have conflicting vocabulary. People are going to talk about it in different ways because they can trigger reactions in multiple places. And they can also be where the rules of the game change. So say you have something like an order. When you get to order shipped, you probably can't now change that order, or maybe there are special rules for updating that order now that it's shipped. And so that is an example of a pivotal event. Sometimes they're called boundary events or key events, just to add a little bit more terminology to you. Now, what these can help you to do is to identify bounded contexts. Now, if you know anything about domain-driven design, you may have heard of bounded contexts, but these are basically, if you're going to be trying to work out how to split up your system, these are going to end up being the boundaries. They're going to be things like modules or services, eventually. And where we've got these pivotal events in between, you're going to end up having an extra model. And what that model does is it's going to translate from the model in one bounded context into the model of another. And so this is really useful for mapping out your systems and getting all that information out of everybody's heads. Much more useful than getting people to write down requirements. Now, event storming comes in 3 delicious flavors. There's rum raisin, my favorite. No. There's big picture, which we just talked about. So this is discovery-oriented. We're working out either what should happen or what does happen. And you're going to have lots of people involved there. You're going to have business and tech involved. There's also process modeling. Now, this is when you're kind of breaking things down further, and this is design-oriented. So we're going, right, okay, now we know this is a particular subsystem, and we're going to go down into more detail, and you're going to have smaller, more focused groups for that. And then there's also software design. Now, this is normally either technology or kind of user experience design-oriented, and you're going to have a smaller, more focused group for those as well. So that was event storming. Now we're going to go on to event sourcing. Now, so far, we've talked about events as transmitting information from one place to another. Now we're going to talk about storing information, which, of course, is another form of communication in itself. Now, with databases, there's lots of different types, but when we're talking about things like relational databases, document databases, we're talking about stateful entities within them. Those tables are stateful. And so when we update information, it gets overwritten. Now, this means that whenever we look at that document or that table, we are looking at the current state. So when someone wants you to debug a problem that happened 2 weeks ago, if you look at the current state in your database, it's not really going to help you. So you're going to need either a backup or logs so that you can somehow recreate that data. So we see the current state when it's stateful. Now, with sourced entities, we store things so that every time the state changes, we store what has changed. It's a little bit like time travel, but also you can think of it like versioning your code in Git. What we're seeing here is a history of the state of your data. Now, most people wouldn't imagine not versioning their code these days. There's still some. But if you think about it, most people wouldn't think of versioning their data. But imagine this. Imagine your code base is lost, but you've got your data. You could rewrite that code, couldn't you? It would take a little while, but you could rewrite it. What happens when you lose your data? Can you rewrite that data? Nope. So, versioning data is a good idea. Now, within an event store where you have got all your event sourcing data, you have streams. Now, this is not streaming like we were talking about earlier. This is another term that means different things in different contexts. So streams are the changes in state for an entity or an object in your system. And so what you get is lots of separate streams. Now, it's good practice to keep your streams relatively short, so that when you're reading them, it's much quicker to actually read them. Now, what you can do is you can split them on things like business life cycles or time frames. So it might be at the end of a process, you would stop that stream and start a new one, or it might be something like end of day, end of month, depending on how many items are going into your stream in that time. Now, when I show the slides, there's a load of further reading links at the end. And so if you're interested in more information on any of these things, there's going to be loads in there. And that includes these life cycles and how long they should be. Okay, so when we read from these data sources, we are reading each change and then building up what the current state is. And so this means that if you do need to recreate an historical state, you can just read up until the last event, but before that time. And so you can build up exactly what it was last Tuesday at 9:05 p.m. when everything went a bit haywire. Now, there's a few different ways that you can do that. It will depend on the event store you're using, but there are things called projections, read models, and basically you can use these to then build up a cache of what the current state is. So you don't have to go and read from the event store every single time. Now, speaking of event stores, there's a quick disambiguation here. They are where you're going to store your event sourcing data, as I've just said. Now, what you can do is you can use a non-specialist data store like Postgres. And there are also things like Martin and MessageDB, which act as a wrapper and allow you to then use them as an event store, Postgres as an event store itself. Now, there are also very specific databases for event sourcing, and one of them is called Event Store DB. So there's your disambiguation. We've got the generic term, and we've got the product. It's a bit like a Hoover. A Hoover is what a lot of people call it, a vacuum cleaner, but it's also the brand name. And what these event stores are, is they are write once and read many, because they are immutable. We're not going to change anything that we've written in there. So we write it once, read it as many times as we need. Okay, tombstone event. This one is not as depressing as it sounds. Now, a tombstone event can be generalized to, this data is no longer there, which, yeah, that kind of makes sense. But tombstones are also context specific. Hooray, everybody uses them in different ways. So when you're using a particular piece of software, you're going to have to work out what it does with tombstones. Now, they were particularly useful for things like C and C++, where if you had a dangling pointer to memory, it could cause serious issues. And so they're used there to stop memory that's in use being overwritten. Now, in event sourcing, we have a few different ways that these are used. So in the different event sourcing, it's generally like this is the end, or we're going to delete it. So in event store, it's used to mark a stream for permanent deletion. But in Martin, it is used where we have got a transaction failing. And so it said, that failed, but I don't want there to be a gap in my global reference numbers, because that can cause problems with building out asynchronous projections in Martin. And so, two different ways of doing this, but they both do mean that this data is no longer here. Now, Kafka is for streaming, and there is a pattern in Kafka called maintain order of redirected events. Now, basically, this means that if event 1 comes in from a particular topic, and for some reason that Kafka main app can't process it, maybe there's a missing dependency, it will put it on this retry topic. So when event 2 comes in, what it's done is it's stored the ID of event 1 in that little database that it's got there, and it goes, oh, I need to maintain the order of this, so even if it can process event 2, it's going to put it onto the retry topic as well. And then we've got this retry app, which is going to keep retrying. Now, when that retry app manages to process those events, what it does is it creates a tombstone for them, as well as putting them onto where they should be going. Now, you might think that's a bit weird. Positive thing has happened, and it's created a tombstone for it. But what it's saying is that data is no longer here. So it does kind of make sense. And so what the main app does is it looks out for these tombstones, and once it sees them, it can then remove that ID from its local store. And so when event 3 comes in, as long as it can process it, it will do so. Now, this is this is verging on a command, really, these tombstones, because remember I said that events are, this happened, I don't care what you think, this happened. Whereas this is kind of a bit more, I'm expecting you to stop sending these things to me because I'm giving you these tombstones. So it's a little bit on the verge of a command here. So something to think about there. Okay, domain events and integration events. These are great. These cause no end of confusion. So what I'm going to do is I'm going to give you some new terms to use instead. And they're not going to be new terms to you. Okay, so who here knows about the DDD Blue Book by Eric Evans? Ooh, quite a few. So that's domain-driven design. The term domain event wasn't actually in the Blue Book. It came about after he published that, and the Blue Book's over 20 years old now. But it is in the Orange reference book, and you can download that as an ebook from his website. And what it's defined as is something happened that domain experts care about, a representation of something that happened in the domain. So this is what your stakeholders are actually caring about. These are the things that we're putting on those orange stickies. Now, you may have heard of domain events being things that either run in process or run, say, in a subdomain or a domain. And then what we have are integration events, and we use those to communicate between domains. But the thing is that if you think about that definition, integration events are also domain events. They're probably the events that your stakeholders care the most about. They're these pivotal integration events, and yet we're kind of calling them integration rather than domain. So what we can do here is we can think about designing events in the same way as we design our APIs. And Oscar and Nick both agree with me on this. So we don't get domain and integration APIs, do we? We have private and public APIs. So how about we use those terms instead? All of these are domain events because we care about all of these different things. But what we then have are private events. Now, these ones are in your domain or subdomain. You are in control of those. You can version them. You can do whatever you want with them, really. Then we have these public events, and these are the ones that are going to need to have that shared model. You're going to have to version changes in these so that they can be understood when they are received somewhere else. So there you go. 2 new terms for you which aren't new because you use them with APIs. Now we're talking about the design of events. Let's think about the internals of our events. I'm going to talk to you about event granularity. Now, what should you put in your events? It depends. So I'm going to show you a continuum here. It's not the Q continuum, but it's that sort of thing. So on one side, we have less data, and one side we have more. You may have heard of these referred to as thin and fat events, but I think that's one of those terms like master and slave that it's best that we move away from. So just think of them as less and more, or you can think of them as notification events, where it's just saying something happened. Or we can have context events, where we've got events where they're giving you lots of information around it. This happened, and these are all the other bits of connected information. And then we have a status in the middle, which is basically saying, something happened, this is what changed. And what we get here towards one side, not with the very low amount of data, is we get what's called event-carried state transfer. And this is the kind of thing that we are aiming for. But why should we care about this? Lots of reasons. But among those are, if we're down this end, we've got what Oscar likes to call a clickbait notification, a clickbait event. Now, this is basically completely useless unless you go back to the producer and say, okay, something was updated, what? Go on, tell me. So you're having to go back across that network again, you are increasing your latency, and what happens if that producer is now not available? What happens if that data has now been overwritten? It's gone. You may as well have put it in there in the first place. And then at the other end is what I like to call all the things event. So we've got everything in there. Now, you don't then have to call back to the producer, but you've got lots of coupling, because if you change anything in there, everybody's got to then update. You've got to think about having backwards compatibility. You're also spending a lot of processing time putting this thing together, and you're using energy and resources to transmit it, and that's not good for the environment either. Now, the common advice is to make events as small as possible, but that doesn't really communicate what it means. What it should be is as small as possible and as large as necessary, because what we want is this event-carried state transfer. We do not want that consumer to have to call back to the producer. We want it to have the information it needs. Now, it may need to talk to other services to do what it wants, but it doesn't need to call back to that producer at all. And then we avoid those problems that we get with the clickbait and also the all the things events. Now, you were just thinking that there weren't enough types of events in this talk, weren't you? Yeah, no you weren't. But I've got a little bonus event for you now. And this one is the non-event. Ready? It's a non-event. Sorry, I couldn't resist putting that in. So today, we've been on a tour of all these events and event-related concepts, even a few alternative names along with that. Now, I can't say that I have covered all the different types of events and concepts today, because people keep inventing new ones, and I can't put everything in a 50-minute talk either. But what you've got is the most common stuff to help you navigate through this landscape of events and all their related things. Now, for anyone who's keen to get ahead, I offer multiple training courses and talks via the Ministry of Software Design. Those are just a couple of examples. So if you check out my website, it's got all the information on there, and I do tailored packages for people as well. Lots of different topics, software design and software architecture. And so I want to say thank you very much again for your time and energy here. And please find me on the internet, but I believe we have some time for questions if you have any. Yep.
Does it make sense to use event-driven design
Okay, so the question was, how does it make sense to use event-driven design if not everything is within your control? The answer is, of course, it depends. But the things it depends on are what is the problem that you're trying to solve. If your sort of sphere of responsibility has got something that is going to be solved and you think event-driven is going to be the best thing to do here, and you have the ability to do that, you can create something that's event-driven within a bigger ecosystem. You're going to have to think about your interfaces with the other systems, so maybe you're calling to an API or something is calling into you. But if event-driven is going to solve your problem, and it's you've got to look at the trade-offs, like, do people understand this? Is it going to take a long time to implement? Is this going to cost lots of money? But once you've done that, and it's quite a good idea to actually get input from lots of people, maybe create an architecture decision record, get input from different people, and if you then decide that, yes, that's what you want, then yes, it can work. Any other questions? No, you'll want to grab a drink before the end note. Okay, so thank you very much again, and feel free to come and grab me.